Alright, thank you for the attention. And for today, I want to presentation my PPT. For the first, I want to introduce myself. Alright, my name is Alviyer with name 190107775. So the title of my presentation for today is Applying the Plain Nucleic Egg or PDCA cycle to reduce the defect in the manufacturing industry, a case study. So for the first is about introduction. So we know about lean manufacturing. So lean manufacturing is a philosophy that is applied to production systems, and this philosophy was developed in the Toyota production system and rapidly established in the manufacturing industry around the world. So according to Botti et al., the main features of lean manufacturing includes 6 lean manufacturing. For the first is just-in-time practices, for the second is work in progress, and the third is waste reduction, and the fourth is improvement strategies, and the fifth is defect-free production, and the sixth is work standardization. So, however, even today, defective products and components are present in the manufacturing industry, and this is a critical situation that companies in this sector are facing. And even after proper care in the design, material selection, and product manufacturing, there are defective parts. And to reduce or delete wastes, such as defects, lean manufacturing provides 25 methods, technique or tools, and some of them are 5S, just-in-time, Kaizen, and planned nucleic egg or PDCA cycle. And for these cases, this project only uses PDCA cycle. So for the literature, for the first is IPC. So accepted in all the world as the key manufacturing standard for the industries of manufacture of printed words and electronic products. The IPC standards are related to most of the development cycle stages of electronic products. So the IPC standards have to guarantee a better quality, reliability, and consistency on the electronic assemblies that are part of an electronic product. So there's have 4 IPC standards are the following. For the first is IPC A 630, and the second is IPC A 600, and the third is IPC 4101, and for the fourth is IPC A 610E. So in these cases, we only use IPC A 610E. So for the 4 standards, the following, it's all the accredited by the American National Standards Institute or ANSI. So next is why we choose IPCA 610E. So why we choose IPC? Because with regard to the standard IPC A 610, it is a collection of visual quality, acceptability requirements for electronic assemblies, and quality acceptability criteria are not focused on defined processes to perform assembly operations or authorize the repairing or modification or change of final product. In this specific case of the components named through holes, the quality acceptability criteria of welding are the following: there are no safeties or imperfections on the surface, and the terminal and the track have good wet conditions. The terminal is discernible. There is 100% welding filament around the terminal, and the solder covers the terminal and the forms are smooth, finished with the edges on the conductor tracks, and the last is there's no evidence of raised filament. So the next literature is PDCA cycle. So the PDCA cycle was used as a tool for the quality control of products. However, rapidly it was highlighted as a method that allowed developing improvements in the process at organizational level. So the PDCA cycle is characterized by its continuous improvement approach, and it is recognized as a logic program that allows improving the activities. And several authors state that the PDCA cycle is much more than a simple lean manufacturing tool. And next is why these cases choose PDCA cycle. Yeah, we know before PDCA cycle is much more than a simple lean manufacturing tool, and there's have 4 stages of the PDCA cycle. For the first is plan, do, control, and act. So the first is plan. Plan, in this case, improvement opportunities are identified and later priorities are assigned to them. And likewise, the current situation of the process to be analyzed is defined by means of consistent data. The problem causes are determined and possible solutions are proposed to solve it. And the second is do. So in this phase, it is intended to implement the action. In the action plan, select and document the information. So also unexpected events, learned lesson, and the acquired knowledge must be considered. And the third is check. So in this step, the result of the action implemented in the before step are analyzed. So a before and after comparison is performed, verifying whether there were improvement and if the established objectives were achieved. And to this, several graphic support tools such as Pareto chart or Ishikawa diagram can be used. And for the last is act. So this phase consists is developing method and aimed to standardize the improvements. In addition, the proof is repeated to obtain new data and retest the improvement, and or the project is abandoned and a new one is begun from the first stage. So according to several authors, among the quality tools most used by the companies and that serve as support to the PDCA cycle are the 5S, failure mode analysis and effects, or FMEA, and 5YY1H or 5YY2H, brainstorming, benchmarking, statistical process control or SPC, checklists, Ishikawa diagrams, and the Pareto chart. And then there are quality function, deployment or KFD, the flowchart histograms, single minute exchange of die or SMED, Pokayoke, Surf Qual, Times Quality, and Six Sigma. And in this project, the graphical tools of Pareto chart and only use two. There is Pareto chart and the flowchart. Okay, next. Okay, so for the next literature we use is Pareto chart. So the Pareto chart is a special type of bars chart in which each bar represents a different category of or a part of a problem. So despite this type of chart illustrates the distribution frequency of descriptive data classified in categories, and these categories are placed on the horizontal x and the frequencies on the vertical x. So talking on categories, they must be in descending order from left to right, and whereas the accumulated percentage of frequencies is represented by a line, and the highest bars represent the most contributing categories to the problem. So Pareto chart help to identify how much some specific factors influence on a problem in a relation with other factors. For example, Pareto charts help to identify the best improvement opportunities. So Pareto chart has the following advantage. For the first is it decomposes a problem into categories or factors, and the second is it identifies the key categories that contribute the most to a specific problem. This means prioritize the vital problems over the trivial ones, and the third is it shows where to focus efforts. So next is how about Pareto chart? So as in the case studies of PDCA cycle, literature review shows that the Pareto chart is a useful tool to detect the most frequent defects in the process or product. Therefore, we selected the Pareto chart to detect the most frequent defect in the welding process of the manual finish area. So, okay, the last literature is flowchart. So, flowchart is a visual tool that shows the workflow for a specific work process, facilitating the understanding, standardization, and improvement of such process. And a flowchart is a picture that contains the steps of a work process. And there is half for the flowchart provides. There is it allows identify the sequence or of necessary steps to perform a task, and the second is it allows identifying the relationships among the steps, and the third is it highlights the transferences, the places from where the process flows from a person to another one, and the last is it allows for detecting problems in the analyzed work process. So why flowchart? So it uses different symbols to represent different types of activities of a process. So for instance, it uses boxes or rectangles to represent the activities or steps of the process or task, ovals or cycles to indicate the beginning and the end of the process, diamonds to indicate that decision must be made, as well as rows to indicate the sequence of said steps. And the necessary steps to perform a task can be identified by means of a list. A flowchart is easier to interpret, follow, and remember. Moreover, a flowchart allows identify the process to be analyzed and the total steps in the process and the beginning and the end of the process. So for the next is results. So in result there have three phases. For the first is results of phase 2 and phase 3 and phase 4. So for the first is result of phase 2. We look at figure 2. It shows that the layout and flowchart for the manual finish area, As we can be seen, the production of electronic boards was performed in 8 tasks. There is manual ink, manual assembly, wave soldering kind, touch-up, hand soldering, inspection, finish out, and quality assurance. So improvement opportunities were detected in the task of manual assembly and wave soldering kind. And the main defects detected in the wave welding process, and that represented the 80.8% of all defects, were solder breach, damaged component, missing component, wrong component, left component, exercise holder, reverse component, insufficient solder, and pin damage. So for the next is we see figure 3. For figure 3, it shows the result in a Pareto chart for the defects that were detected in the manual finish area during the period of August to December 2017. And we look to figure 4. It shows a Pareto chart with the product models that had the highest number of defects. And for next, if we look for figure 5. On figure 5, it shows the defects that were detected in model 595407 XX00. And if we look for figure 6, it shows the defects detected in model, and finally defect detected in model from figure 7. So for the next, we see for results of phase 3. So for results of phase 3, result indicated that all necessary fixtures were purchased for each model, and in the wave welding process, these new fixtures helped to decrease the number of defects in comparison with the old fixtures. Other results indicated the workstations of manual assembly didn't have defective parts, and similarly, in the workstation of touch-up, there was an instant improvement since the touch-up process time had decreased. And at the same time, this result led to an increase in the product quality, since the number of times the electronic boards were retouched was decreased, which in the beginning caused them to wear out, was reduced. Likewise, an increase in production was obtained in the 3 analyzed models, since the average time in the touch-up stations were reduced. So for the next, there's half result phase 4. At these stages, results were presented to the managers, who approved standardizing some changes in the wave welding process, and some of the standardized changes were the use of fixtures with a new design, depth of visual aids with real photos of the electronic boards, in which notes for the electronic boards with polarity were added, specifying the correct positioning of the board. And similarly, some parameters such as light temperature, fan speed, wave speed, conveyor width, and flux amount, were changed and standardized for the 3 models. So for the last, it is the conclusion about this case study. The 3 tools help to globally increase the competitiveness of manufacturing companies, as in the case of the case study shown in this project. And With respect to the objective proposed in this project, it is concluded that the objective of reducing at least 20% the defects generated by the wave rolling process in the models with the highest sales volume in the manual fins area was achieved, since the number of defects on the three analyzed models decreased by 65%, 79% and 77%. And on the other hand, with regard to the objective of increasing the capacity in the three model production lines of the electronic boards by at least 20%, it is concluded that also this objective was achieved, since the result was 19.72%, which had a difference of 0.28%, which it is considered to be non-significant. And then this result allowed the company to be closer to complying with the IPC A610E standard, since a high percentage of the electronic boards of the analyzed models managed to meet the criteria established by that standard. And for the last conclusion is, based on the result in this case study, it is recommended to replicate the PDCA cycle in the other models, present more defects such as like models of 532053, XX00, and BOM 1500796 XXS, and 59644800200, to name a few. So thank you to all of your attention. I say thank you.